All right, guys, welcome to lesson 2. I wanted to kind of go over it with you. You did the Desmos activity and kind of tried to answer the questions and read and see what you could understand on your own. But let's talk about some of the things you did talk about. Let's represent and analyze data using dot plots, histograms, and box plots. This lesson primarily focused on histograms and box plots. So a histogram, it asked you to kind of look at this data and create a frequency chart. So to make the frequency table, you needed to count how many numbers were in each category. So if you're looking over at your data here, you can see that 47 is the only value that fits between 40 and 50. So you have an interval of 10 there. So we're going to put 1. The next interval is between 50 and 60. So I have 1, 2, 3, 4, and I'm not going to include that 60. So I only have 4. 60 does not go into this interval 50 to 60 because it goes from 50 up to 60, and 60 will be included in the 60 to 70 interval. So then from 60 to 70, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. From 70 to 80, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. From 80 to 90, 1, 2, let me change colors here. 1, 2, 3, 4, 5, 6. Oh, that's a bad 6. Let's fix that. And the last one, I just have 190, so 1. So my table's filled in, and all we had to do was count how many values fit into each category. And let's clear the screen and go to the next slide. Maybe. So your histogram should have came out looking like this. We simply plot how many were in each one. So from 40 to 50, there were 1. So our bars went up to 1. And then 50 to 60 was 4. And then 9, 9, 7, 7, 6. And then 1 again from 90 to 100. The next one, you were asked to make a histogram that changed the intervals. So we switched them from intervals of 10 to intervals of 5. And I gave you that frequency table. So all you had to do was draw the histogram, and it should have looked something similar to this. On the next slide, we're going to compare the two. So here, we kind of already talked about some of the questions. So I asked in the lesson where you put the 60, and the 60 went with the interval 60 to 70 and not the interval 50 to 60 because it is included in the low number. So this category only has 50 and includes all the numbers up until 60. And then we would have 60 all the way up until 70. The next question I asked was, what information is easily seen in a histogram? And so if you're looking at these histograms, the shape of the distribution as well as estimates for the measure of center and measure of variability are here. So you can tell that majority of the tomato plants were right here for this one, and it is kind of like a bell-shaped. But when we changed the interval from 10 to 5, our shape changed. So you can see that it kind of dipped and then went back up and down. So you can see that dip, and it makes it a little bit more precise when you make the interval smaller. So the next question, according to each histogram, what appears to be the typical number of days it takes a tomato plant to produce tomatoes? So using the first histogram, it appears that the typical number of days is somewhere between 60 and 80. So you can see right here, 60 to 80 Both of these had 9 tomato plants that grew there. But if we look at the second one, it appears that the typical number of days could be anywhere between 75 and 80 because it is now the interval with the most tomato plants. And so making our interval smaller allowed us to see a little bit more detail into where the data actually was lying. Okay. The last question I asked you about histograms was what information is not seen in the histogram? So looking at histograms, you were not able to see the actual values. You only know the number of values within an interval rather than the values themselves. So we only know that 6 tomato plants were between 75 and 80. We don't know how many days those tomato plants actually took to produce fruit. We only know that they fell in that interval. All right, the second thing that we looked at today was a box plot. And so to look at a box plot, we had the same set of data. We're still talking about tomato plants and how many days it took them to produce fruit. The first question asked you to find the median. And so to find the median, you simply find the number that is in the middle of your data. So median is the number in the middle of your data set. So if you need a process, you can start by marking off either end of the data until you find the number that is in the middle. Okay, so we can just keep going. Make sure your numbers are in order. And so for this activity, the numbers were already in order for you. And so you get to the end and you have 2 values that are in the middle. So when you have an even number of values, you have to find the number in the middle of those 2 numbers. And so there's 2 ways you can do this. We know that the number in between 70 and 72 is 71. Okay, if there were values that included decimals or fractions and a little bit harder to see what's in the middle, just add them up and divide by 2, and that will give you the number in the middle. Okay. The second thing that you're asked to do is to fill in the quarter 1 value. And so you're going to look at the smallest half of your data. So that number that we just found, 71, fits right here. And so that splits our data into 2 separate sections. So the underlined numbers are now the lower end of your data. And to find that Q1 or the first quartile, we're going to find the median of only those numbers. Okay, so I'm going to start by marking them off the same way. Okay. Okay, and you end up with 62. So your quarter 1 value is 62. All right. On the next slide, it also asks for your quarter 3. And our quarter 3 value, you do the same thing with the top half of the data. So we're going to simply go 72, 90, keep marking them off until you get to the middle. And our middle value here is 78. All right. And our minimum and maximum are the last 2 numbers that they ask. And so you simply look for the smallest number, 47, and the largest number, 90. So what these values represent in context of our problem, the minimum, it means that there was one plant, it took 47 days for it to produce fruit, but another plant had the maximum time. It took 90 days for that plant to produce fruit. The quarter 1 tells you, think about a dollar. If you split a dollar into 4 quarters, a quarter is worth 25%. So quarter 1 tells you that 25% of the data, or 25% of these tomato plants, took 62 days or less to produce fruit. The quarter 3, well, if I have 3 quarters, I have 75 cents. So it means that I had 75% of my data, or 75% of the tomato plants took 78 days or less to produce fruit. And then median means that 71 days was the middle amount of time that it took for a plant to produce fruit. So that means that half of the plants took 71 days or less, and half of the plants took 71 days or more to produce fruit. All right. And let's go to the next slide. So we need to use that data that we just came up with to create our box plot. So let me put those numbers back in. We had 47, 62, 71, 78, and our maximum was 90. So what you're going to do to make your box plot is I like to start and just put a dot where these values lie on the number line. So at 47, that's my minimum. So I'm going to go to where about 47 is and put a dot. And then 62 is my quarter one. So about where 62 is. 71 is the median. 78. And 90 for my maximum. So to start off your box plot, you can go ahead and just connect the first two dots and the last two dots. And that leaves you with one dot in the middle, which is your median. And to connect those, we're just going to draw bars going through them at about equal lengths and then turn it into a box. And we have our box plot. So the two outside ones are the minimum and the maximum. And then we have our quarter one, quarter three, our median is in the middle, and our max, and our minimum. So all of those parts can be labeled and we can tell what they are. So all of these numbers right here is considered your 5-number summary. So anytime you hear something ask for a 5-number summary, that's what it's talking about. Your minimum, quarter one, median, quarter three, and your maximum. I also asked you what type of information is easily seen in a box plot. And so this would be the information you see in your 5-number summary, your minimum value, quartiles, including the median, and the maximum value. So this also alludes to our interquartile range, which we'll talk about at a later time. And then I asked you, according to the box plot, what is the typical number of days it takes a tomato plant to produce fruit? And so if we're looking at a box plot, we would look at our median, and it would be 71. Okay. All right, I hope that cleared up some things for you. So let's wipe that clean and we'll compare the three. So what information can be seen easiest in a dot plot, histogram, and a box plot? So for these, what can be seen in a dot plot? So the dot plot shows the actual values, the shape of the distribution, and the most common values are things that you can easily see in a dot plot. So remember, a dot plot is up here. So here's our dot plot, in case you need that labeled. What information can be seen most easily in the histogram? So the histogram is our graph that we see right here. Okay, and the information we can see in a histogram is the shape of the distribution and the most common interval of data. Okay, so we can tell here that most cell phones lasted between 5 and 6 hours. Okay. And then the last one, a box plot, the 5-number summary. So we can see our minimum, the first quartile, median, third quartile, and the maximum very easily in a box plot. All right, let's clear this off. All right, so on this slide, I just kind of put some strengths and weaknesses for each one. So it's important for you to know which graph to choose to represent the data for whatever you're wanting to show. So some strengths of each representation, a dot plot lets you see all of the data and how it's distributed. So if you want people to know exactly what the data points are, a dot plot is a good representation for that. The histogram summarizes the data into intervals to make it uh, look a little cleaner and neater. So if you're dealing with a large amount of data, sometimes putting it into a histogram and showing intervals will allow someone to easily see the shape and how the data is trending. A box plot displays the 5-number summary. So if you want to know those specific things like the minimum, the maximum, the middle, and talk about like parts of data, the quarter 1, quarter 3, a box plot is good for that. Some weaknesses for these sets of data is a dot plot has many columns of dots. That can make it too difficult and a pattern can be hard to see. So if you're dealing with numbers from 1 to 100, 100 columns on there would be very difficult to see. But if you're dealing with a smaller set of data, like 1 to 10, it's a lot easier to recognize. Both the histogram and the box plot don't display individual data. So if you're wanting someone to be able to tell what the individual data sets are, those would not be a good representation. And then the last thing, how do you find a typical value for a data set? So these can vary, but you can calculate the mean, median, or the mode. So these show the average or the number in the middle or one that kind of shows up the most. All right. So these are all kind of things that if we're talking about measure of center, then we would be talking about the mean or the median majority of the time. All right. I hope these things kind of help you and clear some things up. If you're not getting it right now, don't stress out too much because we're going to keep working on these things and maybe it'll start to click. So, as always, if you have questions, feel free to email me. And if we need to set up a Google Meet, I think I'm going to send out a survey this week to see how y'all are doing and see if you kind of want to set one of those up so that we can chat sometime this week. Have a great day.